Welcome. In this session on natural deduction, we'll explore proofs where we have multiple quantifiers. Let's suppose that the first sequent we want to prove is that for all x and y, if y is p, then x is q. And suppose that from that we want to conclude that if something is p, then everything is q. And this is a rather odd sequence. This is not the sort of thing that would come up in ordinary discourse with your friends. But this is logic. Let's get at it. We start with a premise. For all x, oh, that's supposed to be a y. For all x, for all y, if y is p, then x is q. And that's our premise. And this might be a long proof. It certainly looks complicated, doesn't it? So from this, let's leave a fair bit of space, and our conclusion is if something is p, then everything is q. And if I explore this, I see that's a universal quantifier. I could try universal elimination, but if I do that twice, I can see immediately I might run into trouble because I have an existential quantifier. And I have a personal habit, which is I try to get rid of those existential quantifiers first, because they're the hard ones. I can put anything, substitute pretty much anything that's free into a universally quantified formula. But the existentially quantified ones, they always have to be fresh. So I take a look at my conclusion. Oh, my conclusion, if I write down the parse tree for that, that's an implication. So I can open up an implication assumption box. I will do that. So that would be justified by implication introduction. It must start at line 2. I don't know how far it'll go. And line 2, I take the antecedent and assume that. So that is, there exists a y that is p. So that's an assumption. And I take the consequent and I write that as my goal formula, which is for all x, q of x. And now I take a look at this new assumption, at this new goal, and ask myself, what could I do next? Here, I see that I would like, one thing that I could do is I could open up a universal introduction box. Here, I could open up an existential elimination box. As I said, my personal preference is I try to get rid of the existential quantifiers first. So what I will do in this proof is I will get rid of that existential quantifier. The way I do that is with an assumption box. And the justification for the box is existential elimination. The line I'm eliminating is 2, and the box I'm using starts at 3. And at 3, I introduce a fresh variable, and I substitute that fresh variable into this formula provided it's free for. And in this case, if I pick w, that will be free for y. So I'll do that. So I'll introduce a fresh variable w. I'll substitute w into this. So I'll get p of w. And that will be an assumption. I then take this formula and I copy it into the box for all x, q of x. And I then ask myself, what could I do next? if I look at this, and I look at this, and I look at this, I don't see anything immediate other than, if I could somehow get that y to be this w, then I'd have this antecedent part, which is sort of attractive. So could I use universal elimination? And the answer is a resounding no, I am not allowed to. The reason is that that would be attempting to dig inside this quantifier, and the rule doesn't let me do that. The rule only lets me handle this outside quantifier. So that attempt wouldn't work. Well, so if I can't get there from forward reasoning, how about backward reasoning? Well, this is a universal quantifier, so what I could do is introduce another fresh variable and say I'm going to get here by means of universal introduction. I'll try that. So for universal introduction, what I would do is I would draw a box. I'll note that that is universal introduction. The box must be starting at 4. I don't know how far it'll go. And line 4 will be, now I need a fresh variable, and so it has to not be mentioned anywhere else, and it has to be free for x in the goal. And so if I pick z, that will work. Z is not mentioned up here, and z is free for x in q of x. So I will have z. I then take z and substitute it into this goal formula. That becomes the bottom line of my universal introduction box. So that is q of z. And now I ask myself, what could I do next? Well, now I'm in a place that I'm a little more contented, because I have 2 fresh variables, I have 2 universal quantifiers. I bet that I can do some substitution now. So let's see, if I wanted to replace x, would I use w or would I use z? There are only 2 possibilities. I see that my goal is q of z. Here it's q of x, so I'm going to do the substitution here using this inner variable, not the outside variable. So that would be, I would take this formula, I would remove this quantifier and substitute x into what remains. So that would be, for all y, p of y materially implies q. Now I do the substitution, and I've justified that by universal elimination of line 1, and that is now justified as line 5. Then I ask myself, what could I do? Well, here I have a universal quantifier, and I would like to replace it. So the question is, the thing I'd really like to replace it with is w. Am I allowed to do that? Well, the answer is yes, as long as w doesn't get bound by that substitution. I check w, there's no quantifier in here that mentions w, so w's fair game. So that means that I'm allowed to write p of w implies q of z, and I did that by universal elimination of line 5, and that is now line 6. So what could I do next? Well, if I look at this and I look at all of the preceding lines that are within scope, as I go up I see, oh, p of w is in a line. It's a justified part of my proof. So that could be the antecedent. Does it matter here that the antecedent has one variable and the consequent has another? No, it does not. So that means that I could deduce q of z by a rule of propositional logic, which is I could say that's implication elimination based on this is the antecedent, 3, and the implication line is 6. So that becomes the next line in my proof. I've completed this box. That justifies this statement as the box that starts at 4 and ends at 7. That becomes a line in my proof. I've completed this box. That means this statement is justified. It's justified by a box that began at 3 and ended at 8. So that's a line in my proof. And this box is now complete. This statement is justified as implication introduction by a box that started at 2 and ended at 9. And my proof is now complete. That was worthwhile, wasn't it? Well, let's try another one. Let's see if there's one way in which existential and universal quantifiers commute. They don't always commute, but there are some cases where they do. So let's try to say if there's an x such that for all y there's a relation between x and y, I can conclude that for all y there exists an x such that that relation holds. And if I was to try to prove that, I would start by writing the premise, which is there exists an x for all y that relation holds, and I would then write as my conclusion for all y there exists an x such that that relation holds. I would then ask myself, what could I do next? And I could try existential elimination. That would be forward reasoning. Or I could try universal introduction. That would be backward reasoning. If I was to try forward, I can see I might get into some kind of trouble. If I imagine eliminating that, then my assumption would look like for all y are of, let's say, w, comma, y, and then I'd have a for all y, and then my goal formula would get copied in, and it would be a for all y, and there's an exists x in there, and that just doesn't feel very good. So I don't like that idea. Oh, by the way, that's a premise. And so what I'll do is, if forward reasoning isn't helpful, how about backward reasoning? Well, backward reasoning would be that I try to introduce this, and then when I do a substitution, I have a simpler formula. I like that idea a little better. So that's the one I'm going to use. So what I'll do is this. I will say this is justified by universal introduction on, that would start at line 2, and I'm not sure how far I need to go. Line 2 is simply a fresh variable. So let's say I'm getting rid of y, the next letter in the Latin alphabet is z, so I'll use z, I don't put anything here, and I now substitute z into this provided z is free for y in this. Z is free for y. Notice that there is a quantifier in there, but that's okay because z is free for y. Y does not become, z does not become bound when I substitute it. So I do the substitution. I write there exists an x, r of x, and now I do my substitution. And I now take a look at what I've got and say, what can I do next? Well, now it looks a little better if I try to get rid of that existential quantifier. So I think that's what I'll do. So now I need this here I have to be super careful about a fresh variable. So it has to be fresh for everything. So starting at line 3, it has to be fresh. I can't reuse this symbol, and it has to be free for x in that. So let's say that we're going to introduce w. So what I do is I open up a new box, and this line will be justified as existential elimination. It will use line 1, and it'll be a box I must be starting at 3. And then I fill in the top line of the box, which is the existentially quantified formula with the fresh variable substituted. I said I was going to pick w, and I then do that substitution, and that is for all y r of x, and my new, oh sorry, that's a r of w for all y. So that's an assumption. And I then take this goal formula and I copy it as the bottom line of my assumption box. So that will be, there exists an x such that r of x, and now that's z specifically. So now, what could I do? Well, this is a universal quantifier, and I can eliminate that by a substitution with anything that I feel is convenient. Well, what would be really convenient is if I substituted this variable here. Am I allowed to? Well, yes, I can substitute anything at all as long as it doesn't get bound in the process. Could I do z? Does z get bound in that predicate? No, it does not. So I could then say that the relationship holds between z and, between w and my z. And that would be universal elimination based on line 3. So that line is justified. That is now line 4. And if I have a relation that is holding between, now I have two specific fresh variables that I'm mentioning, and I could existentially quantify either one of them. Which one helps me the most? Well, that would be replacing this w with an x. So I could say that this is justified by existential introduction of line 4. And that is justified, so that's line 5 of my proof. This box is now complete. This line is justified by a box starting at 3, ending at 5. That is now a new line of my proof. This box is complete. This line is justified by a box that started at 2 and ended at 6. That's now a line in my proof. And the proof is complete. When I began this proof, I made a comment that there are only some circumstances under which this is true. You might try at home this exercise. You could try saying, is it possible that from this premise, we could deduce that conclusion? And the answer is, I think that you might be able to come up with a counterexample and demonstrate that that proof doesn't exist.